Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this video lesson, we will be continuing our study of numerical computations for finding roots of equations. We are looking at solving a cubic polynomial equation of state, the Pang-Robinson equation of state for chlorine at a particular fixed temperature and pressure, and this time we are doing it using the Regula Falsi method. Now, in this technique, what we're doing is instead of just simply blindly saying, okay, well, I have a positive and a negative value of my function, xn and xp, then before we were just choosing the midpoint. And now then what we're doing is we're using the slope of the line connecting them to get a better estimate of x nu. And using the equation of a line, this is our expression that we end up with. We also have a way of stopping this using relative error, and it's x nu minus x old over x nu, and that needs to be less than our tolerance. Now, before I was doing this using I used the positive or the negative value because it didn't really matter which one I was doing because I was always going to the middle. Now then, I could always be preferentially close to, say, x negative or x positive. And so I want to make sure that I am using x new and x old, the previous guess, when I do this computation so that I get something that works reliably. The programming logic is virtually identical to what we had before. And in this case, I'm going to bring in my input information, the two endpoints, and I'm going to start my counter on my loop, evaluate the function, and then calculate a new value of x sub n, okay, or x nu rather. And this is the formula. Now this is in fact the same as we had before. It's just had a little bit of algebra done on it. And if you're not sure that this is the same, you go back and try and do that. All you're going to do is get a common denominator between the two groups, and you'll have some cancellation. And so this is my formula for x sub nu. And then I'm going to look at that function and determine whether or not it's positive or negative, and whether or not I'm close enough within my tolerance, decide if I need to go back and do a new calculation for x, or whether I need to present answers. So what I'm going to recommend you do is that you go in and modify the code. Just copy the bisection routine and give it a new subroutine name, and then start making modifications. It doesn't matter whether it's above or below the other routine. It's not going to make any difference. VBA will kind of look at the whole set of code you have there and choose what it needs. Now you need to make sure you put in the correct formula for x nu. Make sure you change the read and write locations. And then also I changed the way that I did my checking tolerances. So let's look briefly at that. So what I did was I started by just saying, okay, the old x, I needed to have something. So I just said, let it be the positive end. Let's pretend that was where I started. Then I do my loop, and there's my change in my counter. And then at the end, before I increase my count and start the loop over again, I assign x old is x new. So therefore, when I look at my error limit, I'm taking the new value of x minus the old value of x over the new value and looking at that for my error limit. So now let's leave and switch over to our Visual Basic. And again, you can look at this, and I've got my old routine for bisection up here. I have that function. I'm still using that function. And then now I have my new subroutine down below. I can come into my Excel. I've got this thing set up over here. I've put in the same tolerance just simply so we can compare these two answers side by side. And I'm going to go to Developer, Macros, and I want to run the Regula Falsi. And you'll notice that whereas bisection took 14 times through that loop, to get 6 decimal places. This only took 3. Okay? And in fact, if I wanted to add a 0 or 2, I added 2. Okay? And I run this again. It only took 4. Okay? So this does converge much, much faster than the method of bisection did. In our next Visual Basic lesson, we will be looking at the Newton-Raphson technique. Thank you very much.